Welcome to today's lesson, which is about the distributive property. In today's lesson, you will learn to draw diagrams of rectangles to represent equivalent expressions created with the distributive property. Use the distributive property to help do computations. So first, let's look at an area model to represent 3 times 24. And you can see I have already drawn 2 area models here, 3 on one side and 24 on the other side. And 3 times 24 isn't the most straightforward calculation to do in your head, and counting the boxes in the grid here, that's a lot of counting. So we can make this an easier calculation by breaking it down like this. So here, this length is 20 units long, and this length is 4 units long. And now we've created some easier calculations for ourselves. 3 times 20 is 60. 3 times 4 is 12. 60 plus 12 is 72 units squared. And we could make it even simpler. So we still have 4 here, but we could break it down, the 20, into 2 tens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we've got 10 and 10 and 4, which add up to 24. 3 times 10 is 30. 3 times 10 is 30. 3 times 4 is 12. And so 30 plus 30 plus 12, again, 72 units squared. And we can represent these like this. So 3 times 24 could be 3 times 20 plus 3 times 4. Or we could represent them by 3 times 20 plus 4. And that's the distributive property. If you multiply 3 times 20 first, and then multiply 3 times 4, that's the same as multiplying 3 by 24. For the second one, we have 3 times 10 plus 3 times 10 plus 3 times 4. And we could represent that by 3 times 10 plus 10 plus 4. So let's look at 3 times 19. So it would be easier to do calculations with 3 times 20. So I'm going to draw 3 times 20. So here we have 3 times 20. And so that's 20 on this side, 3 here. And I could make this 19 and 1. 19 and 1 is 20. So we're looking for 3 times 19. Let's do 3 times 20 first. And we'll have 3 times 20 and then subtract 3 times 1, because 20 minus 1 is 19, minus 3 times 1. We're looking essentially for the area in here. We're looking for this. So 3 times 20 is 60, minus 3 times 1 is 3. So the area is 57. 60 minus 3 is 57. So an equivalent expression for 3 times 19 is 3 times 20 minus 3 times 1, or another equivalent expression could be 3 times 20 minus 1. So let's do some calculations with the distributive property. 3 times 95 first, not so easy, but if we say 3 times 100 minus 5, because 95 is 100 minus 5, that makes it much easier. And 3 times let me draw some arrows first. I'm going to multiply 3 times 100 and then I'm going to subtract 3 times 5. I'm going to say 3 times 100 minus 3 times 5. 3 times 100 is 300. 3 times 5 is 15. 300 minus 15 is 285. And on the right hand side we can use these with decimals. We could say it's already broken out in parentheses. I'm going to draw arrows to show what I'm going to distribute. I'm going to distribute 100 over 0.02 and 100 over 0.15. So I'm going to write that out. I'm going to multiply 100 by 0.02 and 100 by 0.15. And 100 times 0.02 is 2. 100 by 0.15 is 15. 2 plus 15 is 17. So we can create equivalent expressions with the distributive property, and the distributive property lets you multiply a sum. So I'm going to do an example. Times 3 plus 4. That's a sum of 3 plus 4 by multiplying each add-end. The 3 and the 4 are add-ins. We can multiply them separately and then add the products. So you saw today how to draw diagrams of rectangles to represent equivalent expressions created with the distributive property, and you saw how to use the distributive property to help do computations. And that's the end of today's lesson.